All right, and the last topic we're going to get into is formulas. So before we were just dealing with equations, and the difference between formulas and equations are that formulas are equations where you have more than one variable. Okay, so we're going to approach some of these later on in a chapter on measurement, but for now, hopefully this isn't too foreign to you here, but the formula for the perimeter of a rectangle, right, I've got a rectangle shape down here, is given by this formula over here. P, stands for perimeter, equals 2L plus 2W, twice the length plus twice the width. Imagine looking over at this rectangle. Here's your length, here's your width, so right, this distance here is the length, and this distance here is the width. And since it's a rectangle, we can assume that this distance on top of this rectangle is equal to the distance on the lower part of this rectangle, and this side on the right is equal to the side on the left. So you're going to take your length, times it by 2, and then you're going to take your width, and you're going to times it by 2, and you're going to add the two together. And that's going to give you the perimeter, right? The distance around that rectangle. So this is a formula. Before, our equations only had one letter in it. Had like an X or an N or a P or a G. And the goal was to combine them and get them together. Now we're given a whole bunch of different letters, and it seems a little scary at first, but hopefully we can work through this one step at a time. In fact, with these questions, what we're going to do is we're going to get rid of all the other letters. Now, one last little note I want to make down here is that it's impossible for these dimensions to ever be negative. Does it ever make sense to say that the length of a house is negative so many feet or meters, or its width, or its height? Right? It never makes sense for these physical dimensions to be negative. So back when we were doing questions just previously, when we solved something like x squared equals 25, and we square rooted both sides, and we got x equals 5 or negative 5, right? Remember when we came up with two possible solutions? In the case of these formulas, we're going to discard this negative solution because it doesn't make sense to have a negative length or a width or an area or a perimeter or all these ideas. Now, we're never going to have to, just to give you the heads up, you're never going to have to memorize these types of equations. When we get to the chapter on measurement, these will all be given to you, but you're going to see a bunch of them now, and they're real equations, real formulas, I should say, real formulas that you will be using shortly. But for now, don't worry too much about memorizing them. They're going to look a little scary, but hopefully we can piece them together. So let's look at an example of this. So this first example, we're going to try to solve for the letter A in this formula right here, given that a squared plus b squared equals c squared. And it's telling us at the end, oh yeah, by the way, b equals 5 and c equals 10. So this shouldn't look all that much different from questions that we saw before, where we were given some information, and we need to put that information into the equation and then solve for a letter. So let's just start putting these numbers in, the 5 and the 10, into our equation that we started with right here, and see what we have. With anything in math, my word of advice is always just put your pen on the page, or your pencil on the page. Start writing things out. You may have to erase something, but at least you're visualizing it and putting some pieces of the puzzle together. So when we put the 5 in for B, right, there's the B becoming a 5, and there's the C becoming a 10, then we get this equation now set up like this. And I call it equation because there's only one letter now, right? There's only an A. The B and the C are now gone. So now let's keep working with this. Well, a squared, let's not touch him yet. 5 squared, well, that's 5 times 5, that's 25. And then over on the right side, 10 squared is 10 times 10. That's 100. Oh, now we're getting somewhere. Look at this equation now. Now the goal is just going to be to get a by itself. So we're going to rearrange this. We're going to move the 25 over to the other side. So we're going to subtract 25 from both sides. Right, these two are going to cancel out, and we're going to be left with a squared equals 100 minus 25 is 75. Now at this point here, we would want to get a by itself. So we're going to do, right now we're squaring a. So remember, we're going to do the opposite of squaring, and the opposite of squaring is to square root. Okay, so we do that on both sides, and the square root and the square cancel each other out. And on the left side, we're left with an a. On the right, we need to take the square root of 75. Now, this wasn't in the list that I listed previously of perfect squares. So the only way to find this is to bring out your calculator and hit the square root of 75. And I just did that, and it comes out to 8.66. And then the 0.2540, yeah, it keeps going. But we'll cut it off there to the hundreds. Now notice, again, there's no, it's 8.66. There's no negative 8.66 because this right here, this equation, is talking about, actually it's talking about the sides of a triangle. Right? So how can the sides of a triangle ever be negative? It doesn't make sense. So we're going to say 8.66 is our answer. No negative 8.66, just positive 8.66. And that's going to be our final answer for this. We could substitute it back in. I won't do it, but if you want, as a little exercise, you can take the 8.66 and put it in up here. And it should work out that this whole equation up here, when you put in an 8.66 for a, should work out to the left and right side being equal. We'll look at a few more examples in the next video.